So, polar form of complex numbers. What is a polar form? First of all, we have to understand what is polar coordinate. So, this polar form was originated from polar coordinate. We know Cartesian coordinate. Cartesian coordinate is x and y. So, Cartesian coordinate is about x1, y, and z. What about polar coordinate? So polar coordinate is about r and theta and z. R, theta, and z. R is the radius, theta is the angle, z is the height. Polar coordinate, or we call it cylindrical coordinate. Polar coordinate or cylindrical coordinate. Now, here we are not going to deal with the three-dimensional space, so we are not going to talk about, or we are not interested in z coordinate. So we are discussing about x and y and r and theta. Now we will understand how to convert a complex number into a polar form, right? So let z is equal to x plus iy. This is my complex number. Now we will draw this on a Argand diagram where this is our real and imaginary axis. So x is in the real plane, in the real on the real axis. So that would be somewhere here, right? So this distance is x. Then iy, so that means y distance on the imaginary plane. So this is going to be now z. This is going to be z, right? So this is c. Now you know this is theta. Okay, so this is theta. Now suppose the distance between this origin and this point over here, okay, I would say p, OP distance, say r. Okay, OP distance is r. So how to find r? From this diagram it's very easy, using Pythagoras. X squared plus y squared square root, right? So this is r. Now how do you write x in terms of that? So x is nothing but r cos theta, you know, from this right angle triangle. Y is nothing but r sin theta. So what I will do now, I will write z is equal to x is r cos theta plus I r sin theta. Now I can take r out, then I get cos theta plus I sin theta. Now you can see originally we had x plus iy. We have the complex number in Cartesian plane, right? In Cartesian coordinates, we have the complex number in Cartesian coordinates. Cartesian coordinates. Now here, once we convert the Cartesian coordinates into the polar coordinates, we have z in terms of polar form. So we have to know both. So for simplicity, we call it r cis, C-I-S theta, cis, r cis theta. This is called polar form or cis form. So now here we found r, right? So r is the distance from origin to the p point. So that p point represent the complex number. Now how to find r? Now we know r is square root of x squared plus y squared from the diagram. Now z is equal to x plus iy. This is very important. Now z conjugate is x minus iy. Now if you do z bar, if you multiply those two together, so you get x plus iy multiplied with x minus iy. Then this is going to be x squared minus iy plus iyx plus iyx. Then you get minus I squared y squared. So these two are going to cancel. So you get x squared plus y squared. So this is going to be r squared. So now you know z bar is nothing but r squared. So z bar square root would be r. So this fact is very important too. Okay, so we have to express this in polar form. The first question, 1 plus square root 3i. So we have to know that in our Argand diagram, right? So this is imaginary, this is real. The Argand diagram, so okay, so real and imaginary axis. So on the real axis you have 1, imaginary axis you have square root 3. So it's here. So this is square root 3, this is 1, right? So this is your r and this is theta. So now we know z can be written as r cis theta. So that would be r cos theta plus I sin theta, right? So we have to find what is theta is. Now from this diagram you can see r is equal to 2 from the Pythagoras theorem. And if you think about sin theta is nothing but square root 3 divided by 2. So then theta would be 60, right? 60 is pi divided by 3. Theta is 60, sin 60 is square root 3 divided by 2. And cos 60 would be half, makes sense. So now theta would be pi divided by 3, r would be 2, so it would be 2 cos pi divided by 3 plus I sin pi divided by 3, like this. Then you can write this is equal to cis pi divided by 3. See, that's the answer. Okay, so in this question we have to convert this into polar form. Now before we do that, we will see how this looks like. So it's minus 2y here, positive 2 here, so it would be somewhere here, right? It would be somewhere here. So what would be the angle now? So angle would be here, right? So it would be minus now. So this is real axis, this is imaginary axis, right? So this is minus, or you can say 2 pi. Okay, so now however, so this is 2 and real also 2. Okay, so what about your r? So r would be 2 squared plus 2 squared square root. So 2 square is 4, 4 plus 4 8, 8 square root. So that is r. Now what about this theta? Okay, so what about this theta? Okay, so that theta is going to be 1, right? So because if you get the tan theta, it's going to be 2 divided by 2, it's going to be 1. So theta, tan theta is equal to 1, so theta should be 5 divided by 4. Why? Because tan theta is equal to 2 divided by 2. Why? Because this is 2 and the vertical value also 2. So it's going to be 1. So theta is equal to pi divided by 4. Now how to write this? Okay, how to write this? Now we understand that we have to write cis form. So r cis theta. So we know r here, which is square root of 8. Now we need to write cos theta value plus I sin theta value. Now by looking at the values here, right, so you can see the imaginary part is negative here and this is positive here, right? So that means sine should be negative, this should be positive, right? So which quadrant we are looking at? Which quadrant we are looking at? We are looking at the fourth quadrant. Why? Because we know that here cos positive and sine negative here. See, that's how you logically think. So now angle is 45. So now let me construct it in this way. So cos, now it should be in the fourth quadrant, right? So if you want, you can write cos. Now you are going in the negative direction. So negative pi divided by 4 plus I sin negative pi divided by 4. Because you are going in clockwise direction. So when you are going in clockwise direction, that means you are going in the negative side. So this is your z. So now we know cos is a even function. So using that knowledge, what we can do, cosine minus pi divided by 4 is nothing but cosine pi divided by 4. Why? It's a even function. Sine is an odd function, so minus sign comes here, right? So I sin pi divided by 4. Now here when you simplify, you get the same thing, but what we need is the cis form. Cis form you cannot have minus. So this is what our answer is, not this. This is written so that we can do the back calculation and convert that into Cartesian form. So going back here, z can be written as now square root of 8 cis minus pi divided by 4. That would be the answer. Okay, so here polar form to Cartesian conversion. So the example is z is equal to 2 cis minus 2 pi divided by 3. Now we can write this as 2 cos minus 2 pi divided by 3 plus I sin minus 2 pi divided by 3. Now what is cos minus 2 pi divided by 3? What is that value? So this is going to be nothing but cos 2 pi divided by 3. Why? Because it's a even function. So now this minus here I can take out. So this will be minus, then minus I sin 2 pi divided by 3. Okay. So z. Now what is cos 2 pi divided by 3? Cos 2 pi divided by 3 is nothing but cosine pi minus pi divided by 3, right? Yeah, so this is going to be again sine pi minus pi divided by 3. So it would be cos pi minus pi divided by 3 is, what is that value? Pi minus pi divided by 3, so it's going to be cosine but minus pi divided by 3. This one would be sine pi minus, so it's going to be sine pi divided by 3. So sine pi divided by 3 is sine 60, which is square root 3 divided by 2. Cos 60 is going to be half, it's going to be minus half. So this can be written as 2 minus half, then you have another minus over here, minus I, so square root 3 divided by 2. So now you can see, you can cancel all of these 2's. So the answer would be minus 1 minus square root 3 I, and that is z, and that's the z complex number in Cartesian form.